In this last section, I'm going to show you how to calculate what we call a confidence interval for proportions. So in the last bit of video, I talked about confidence intervals for the mean. And so when you don't have a mean, though, what are you going to do? And so there are times when we want to do a confidence interval for a nominal or ordinal level variable. And so that's when we use what's called a proportion. This is also known as the margin of error. So for those of you who are familiar with a lot of polling data, what you'll see at the bottom of a poll is a plus or minus, usually 2 or 3%. And that is a confidence interval for proportions, also known as the margin of error. So we're going to use this data. It is taken from the General Social Survey 2008, and it's asking, did you vote in the 2004 election? And so the response categories are voted, did not vote, and then we have our total, and then we have the missing. And so there were people who weren't 18 at the time, or maybe weren't U.S. citizens at the time, or were convicted felons. And then we have those who don't know or can't remember and no answer. We're going to focus our attention on the valid responses only. And so in this case, I'm going to say that I'm interested in the proportion of those who voted. So how accurate is this 71.8% of those who remember and were eligible? What percent of them really voted? So that's what we're going to calculate, is the margin of error or the confidence interval for the proportion who voted. What we're going to need is a standard error of proportions. So the standard error for the mean is standard deviation divided by the square root of n. However, we can't do that for proportions because we don't have standard deviation. It's not something we can calculate with a proportion. So we are going to be doing what's called the standard error of proportions, and that is this equation here. So we have standard error of proportions is the square root of the proportion that we're interested in, so proportion of success, or probability of success, which in this case is voted, times 1 minus the proportion of success, which is also the proportion of failure, or the probability of failure, divided by n. So here's where we're using a little bit about those probabilities that we talked about in the last section of the schoolwork. So if you remember back, 71.8% of people voted. So our P is going to be that 71.8%. But we don't want a percent, we want a proportion. So P is going to equal 0.718. So basically what we do is we take the percentage and divide it by 100 to calculate that proportion. So our proportion, or you can just move the decimal place over 2 spots. And so we're looking at the proportion rather than the percent. So if we go ahead and plug that into this equation, we're going to get the square root of 0.718 times 1 minus 0.718 divided by, and our n here, if you'll recall, is 3,216. So we're going to have the square root of 0.718 times 0.282 divided by 3,216. Okay, now here's where it gets tricky. We're going to have some small numbers here underneath this square root sign. And so normally I ask you to show all of your work, but you have permission to go ahead and plug this into your calculator as is using the characteristics of your calculator. So in my calculator, what I would do is I'd go ahead and multiply the top part out, and I'm going to end up with the square root of 0.202476 divided by 3,216. You'll notice that this time I did not round to 2 decimal places, and this is really important and key. Because we're working with such small numbers, we want to go ahead and leave them whole until the very end. So I'm going to plug this into my calculator. I'm going to hit my square root button, and then I'm going to do parentheses 0.202476 divided by 3,216 end parentheses. And that way because otherwise you're going to get scientific notation, which is fine if you understand scientific notation. I get confused by it sometimes, so I prefer to just keep it all whole and together in my calculator. And I'm going to get 0.0079. Now again, you'll notice that I'm going to go ahead and go to 4 decimal places because we're talking about proportions. And eventually I'm going to turn it back into a percent. So for this case, I want you to go ahead and go to 4 decimal places when you're talking about confidence intervals of proportions. So this is going to be our standard error. So now we can plug this in to our equation for the confidence interval. So let's go ahead and go to that step. So the next step is to actually calculate our confidence interval. So the equation for the confidence interval is the proportion or probability of success, which in our case, we know that this is going to be 0.718 plus z. And so you have to decide, are we doing 95% or 99%? So in this case, I'm going to say we're going to do a 95%, just for the example. So z then is going to be 1.96. So it's the same as it was in the confidence interval for means. It's the same number. And then we already calculated our standard error of proportions is going to be 0.0079. And so we are going to basically plug these numbers in, and we are going to calculate our confidence interval. So we are going to have 0.718, and if you're lazy like me, you can do plus and minus, so you can just write it once instead of writing it twice. 1.96 times 0.0079. So I'm going to have 0.718 plus and minus 0.0155. So I'm going to have my range is going to be from 0.7025 to 0.7335. So this is my confidence interval right here. So we are 95% confident that the range from 0.7025 to 0.7335 contains the actual population proportion. So let's go ahead and look at what that looks like. Here's what that would look like written out into a sentence. There are 95 chances out of 100 that the range of proportions between 0.7025 and 0.7335 contains the population proportion for those who voted. So you just plug in whatever that variable is and that proportion. Now, if it's easier, you can also think of these proportions as percentages. So we can change this from proportion to percentage. And then just multiply each of these by 100, and you'd have 70.25% to 73.35%. And if you'll recall, our original number was 71.8%. So not a bad margin of error. It's really only plus or minus 0.0155. So 1.5%, either direction of the proportion. And so that would be a 95% confidence interval for proportions. Now you could do the 99%, and all you would do is change the z from 1.96 to 2.57. And if you want to go ahead and do that and check your work, the answer for that is going to be 0.6977 to 0.7383. All right, so that's how you go ahead and calculate that. And we will do lots more examples in class. Thank you. Have a good day.